Hi everyone and welcome back to my YouTube channel. My name is Mohit Jain and today we are going to discuss about PySpark DataFrame functions. In this video we are going to talk about some of the most important functions that is used in PySpark frequently. We are going to talk about string manipulations, data operations and case when statement. If you are new here, this is the second installment of the PySpark DataFrame series. I highly recommend you to watch the previous video for a solid foundation. Let's dive deep into PySpark DataFrame functions. In this video, we are going to discuss string functions, date functions, and case statements. We have already seen how to create a Spark session, so I won't be repeating it over here. We can directly get started with the string function. So in the string functions, there are few functions that we are going to cover. These functions are mostly used every day whenever you are going to develop your Spark application. You are going to encounter with these functions. So let's first start with the substring function. Over here, we are first going to create a data frame where we are going to read a CSV file using spark.read.option. Since this file has a header, so I'll say header is true and .csv. So once we create this data frame, so we are going to show the 5 rows, so I'll pass df.show5 and truncate equals false. So let me execute this and see how the data looks like. So we have a customer data which has first name, last name, company name, address, city, etc. So all these columns are available. Most of these columns are string columns and we are going to apply different operations on different columns. So if you see the first name column, the first name column has the first name. For the sake of these functions, I have added some white spaces on the first name after the actual name. Similarly, before the last name, I have also added some white spaces. And you can see in the address field, we have white spaces at the start of the address as well as at the end of the address. So we are going to use these functions to remove those spaces. Also, we are going to look into some other columns. So let's say if I want to create an initial from the first name, I can take some character out and we can say that first 4 character would be the initial for this particular person. So for this particular operation, we are going to use substring. So let me start with the substring function. So I'll say df.with column. I am going to apply the substring function on and create a new column. So I'll create a new column named initial, and the substring function is in the PySpark SQL.functions. So I'll say that f.substring. It asks for the column name in which we have to apply the function. So I'll say the column name is first name, and we are going to give some more parameters, like it asks from where you want to start the substring. So I'll say that I want to start from the first character itself. So I can pass the character as 1, and the length of the substring, I'll say that I want to take 4 characters. Okay, so let me just show and see whether we are able to create a new column. So we have created a new column called initial, and this column you can see the values are the first 4 character from the first name. So this is how you can use the first name and we can create a new column called initials using substring operation. Similar to substring, there is a new function called as substring index. So let's say I want to create a new column called as a username from the email address. So I want to remove the @gmail.com from the email, and the remaining part would be my username. So to create this particular new username column, I'll use the dataframe.with column. I'll say that the column name is username and the values would be f dot, I'll say substring index. Let me pass substring index, and in the substring index I'll pass the column name. So I am going to apply the substring index operation on the email column. Now the next parameter over here would be the character on which we want to apply the substring index. So the character is @. So substring index also asks for the occurrence of this particular character. So I'll say that I want to use the first occurrence. So whenever it is going to see the @, it will remove everything till the right, and it will only take the all the string which is before @. So in this case, it would be the @gmail.com would be removed from the this particular email, and a new column will contain only the username. So let me just see if it works. I'll say show 5 and truncate equals false. So we have created a new column. You can see that we have removed @gmail.com, and only the username is what we have as a result. Similar to this, we also have a trim, ltrim and rtrim column for a different use case. So let's say in the data set we have white spaces available like this, and I want to remove these white spaces. So whenever you want to remove the white spaces from the right side of a string, it will be a rtrim operation. If we want to remove it from the left side of a string, it would be a ltrim operation. Similarly, if we have the white spaces on both the ends, like on the left, on the right, we are going to use normal trim operations. So what I'll do, I'll create new columns, or rather I'll just update these columns, and we are going to remove all the white spaces from the first name, last name and address column. So let me create a new column with column. Instead of creating a new column like I mentioned, I'll say that the column is still first name, and the value is what we are going to update. So we are going to apply the rtrim, since we have the white space at the right, and we'll pass the column name. So column name is first name. We are going to just run this, and we'll see that we are able to remove the white spaces from the first name. Over here, whenever this function is applied, first the function is applied on the column name, and then only the column is created. So if we pass on the same column name, since it is a metadata, it would replace the previous values, and it will create a new values like after trimming, and it will again assign to the same column. Similarly, for last name, we can again we can use chaining over here. So after one with column, we can again apply another with column. And similarly, if you want to apply some select operations, we can just keep on adding after the with column is applied. So let me say last name, and from the last name, let's say I want to do ltrim. So over here again, I'll pass on the column name as last name, and the third column is address. So in the address column, we are going to apply the trim operation. So I'll say f.trim, and inside the f.trim, we can pass on the address column again. And just to see that we have removed the address like white spaces from all these columns, I'll just select these columns so that it is better visible to us, and we'll just pass on the column names like first name and last name, and the third one is the address. And we are going to just show again 5 rows, and we'll say truncate equals false. We can now see that we have removed the white spaces from these rows. So as an example, if you see the address column, we can see over here that the address column don't have any white spaces. And if we see before applying the trim operation, you can see that there is a white space available or in the address column. Similarly, you can also see that there is a white space available at the left of the last name, and since we have applied ltrim on the last name, it has removed the white spaces, and you can see that there is no white spaces in between. Similarly, for the rtrim function as well, you can see that we have removed the white spaces. So now we don't have any white space after the first name as well. So this is how you can use ltrim, rtrim and trim operation. So concat function is used to concat two different columns using some separator, or if you don't want to use any separator, you can just add these two columns and it will get concatenated. So to apply this, let me create a new column called as a full name, and which will be first name plus last name. So we can apply the concat operation over here. We'll say df.width column, and the column name would be full name, and in the column we can say that f.concat, and in the concat function we can pass on the column. So we can use f.call function. F.call function basically treat the string as a column. So if I pass on the column name like first name, once we pass the f.call, it will understand that okay, this is a column. Similarly, if I want to pass any space in between, like if I want to separate it via a single space, I can use f.lit. So lit function basically is used to create a new column with a static string. So it is going to act as a separator in between first name and last name. Similarly, I'll say f.call and the column name would be last name. And once we say dot show 5 and truncate equals false, we can see that we have a new column called as a full name, and the full name is first name plus last name. Since we had the white spaces after the first name, you can see that there is a gap over here, and similarly you can see on this particular row as well, we have a first name and a last name. This is how we can use concat operation. Let's say we have a new column called as a middle name, and we want to create a full name using first name, middle name and last name. So if we are going to use concat, we have to pass on f.lit and a space every time we are going to add a new column. So instead of doing that, we can use another function called as concat ws. So we can use df.width column. Again, we are going to create, let's say we are going to pass on these three columns, address, city and county. So we want to create a full address column, and this full address column would have the city name, county name as well as address. So to achieve that, we are going to use concat ws. So concat ws asks for two different type of parameters. First is the separator. Let's say I want to separate these columns using hyphen. So I'll pass on the column names like f.call. I am going to pass on address. Then I am going to pass on the city column. So I'll say f.call city. And finally, I want to concat the county column. So I'll say f.call county. Also, let's say since we have the empty like white spaces in between addresses, so instead of directly passing this, I can say that f.trim, so that it will remove all the white spaces that address column have, and then it will concatenate different columns like city and county, and the separator between them would be hyphen. So now let me execute this. Once I have executed it, you can see that there is a new column called as full address, and we have the address over here. So to see the complete address, I will say that show 5 and truncate equals false. Let me also select only the columns that we are using for this operation. So I will say that I just want to see address, and I want to see the city, county, and the last column is the full address. So we can see that after we have applied the concat ws, we have created a new column called full address, and it is created using the separator as hyphen. So you can see there is a hyphen separator available in between, and this hyphen separator basically separates different columns that we have passed on concat ws. So we have address, city and county, and you can see over here as well, I have removed the white spaces. So using f.trim, we have removed the white spaces, and the city is New Orleans, and the county is as mentioned over here as well, and all of them are separated with a hyphen. Once this is done, let's move ahead with the other function. So there is a function called as format string. So we have seen that we can use concat operation, and in the concat operation we can pass on the different column names, and also we can use the concat ws. But let's say if we want to not use the concat operation, so there is a new function called as a format string, and this format string function also does the same. It will be used to create a new column, and that column can be created by using 3 different columns, and we can pass on the format as well. So in the concat ws we just pass the 1 character. We can create a complete string using the values from different column using format string. So let me say that I am going to create a column called as, let me create a new column using the format string. Let me say that the column again is a full name column, and over here I'll say f dot format string. You can pass on the format that you want to specify. Let me say that I'll say the format is first name is %s, which means that first name is over here, and last name is %s, and we can pass on the column name over here like f dot call, and the column name is first name, and the other column name is last name. So what it will do, all the values for first name for each row will go over here, and we'll have a new string called as full name, where we'll mention that the first name is this and last name is this. So this will create a new column, and let me just select only these columns. So let me say that dot select, I'll say first name comma last name, and we have the full name dot show. So if you see over here, so there's some error. Okay, this would be select. So you can see that the first name is James and last name is Bert, and full name is, let me say truncate equals false to print the complete column. You can see that we have a new string, and this column full name has the first name is James and last name is Bert. So we can use format string like this. You can also use numeric columns over here as well. Just you have to keep in mind that instead of %d you have to pass instead of %s you have to pass %d. So it will know that this is a numeric column. So the next functions that we are going to look into are lpad and rpad. So lpad and rpad function is used for padding the string. So let's say there is a column called as a zip code, and we think that length of the zip code sometime is 5 and sometime is 6, and in some cases whenever there is a hyphen in between zip code it can go up to 7. So we want to make sure that all the zip codes are of the length 7. So to achieve that, we can pad this particular zip code with a 0, and similarly if you want to pad at the end of the string, we can use the rpad. So let me apply lpad and rpad and see how it looks. So I'll say df.width column, and inside the column I'll pass the zip, and we are going to say I want to do a lpad, and I want to pass the zip column, and in the zip column I am going to say that I want a length 7, and I want to pad it with 0. And let me just show this. We can now see that zip code is of length 7. So wherever there is a length 5, we have padded 2 zeros. So in cases where there is a length of 6, we would be padding only 1 0. Similarly, if I want to apply this on the right of the string, we can say instead of lpad, I will say I want to do a rpad. So once I apply the rpad, you can see that we have added 0 at the end of the string. But we know that it seems very unreasonable in the zip column, but it may be required for some other use cases where we want to use the rpad instead of a lpad. So this is how we can use rpad and lpad. Let's move ahead with the last function that we are going to see for string operations. So this is one of the most important function because we are going to use these functions whenever we are going to apply some operation on the string of a larger length and we want to just replace some substring portion of a string. So let's take an example. There is an email address column that we have, and let's say I want to change the email from Gmail to Outlook. So what I'll do, I'll use this regex replace function. I'll pass on the column name. I'll pass the string that we want to replace. So in our case, it is a Gmail. I want to replace Gmail with the Outlook. So we'll see that how it goes. So what I'll do, I'll create a new column, df.width column, and over here I can pass on the let's say I want to keep the column name similar, so I'll say email and I'll say f.regex replace, and in the regex replace we can pass on the column name, it is email, and the next parameter would be what is the string that you want to replace. So I want to replace the Gmail and I want to replace it with Outlook. And once I do a show, let me select only the email column. Let me do a select and I select a email column. Okay, let me create a new column called email new for comparison whether the name has changed or not. So I'll say email.width column email new, and here we'll select email and email new. So you can see over here that the Gmail is now Outlook. So wherever it was Gmail, you can see that we have Outlook available over here. So this is how we can use the regex replace function, and this is one of the most important function that you are going to use whenever you are going to do a data manipulation on columns like email. Also, this particular function can be used whenever you want to hide some characters from your string. You can pass on that wherever there is a Gmail. Since you don't want to show the email ID, you can say instead of Gmail you want a ##. So let me just apply. You can see that now the address is now changed from Gmail to some hidden character. So this is one of the use cases of regex replace function. So this is how string functions we can use. So let's get started with the date function. We are going to cover all the date functions that you are going to need whenever you are going to manipulate the data with the date formats. So generally you are going to receive the data in the format of -mm -dd, and if it is a timestamp column, you are going to get the mm and ss, which is a hour, minute and second. In some cases you can get a date in a different format, like you are going to get a date in dd/mm/yy. So whenever you want to convert this particular format into a standard format that is supported by all the systems, which is -mm-dd, we have the capability in PySpark. So there are different functions like a date format function which will help you achieve this particular conversion. So let me create some data set. So I'll say data equals, I'll create the data with two different columns. So in one column I am going to pass on the date as 25/02/2024, and the other would be, I'll pass on the complete timestamp over here. I'll say 2024 hyphen 02 hyphen let's say 25, and let's say this is in the like 23 hour and 30 minutes and say 20 seconds. We can again create a new column, and in this column we are going to pass on the date in the same format which is accepted by PySpark. So generally all the system accepts the date in the YYYY-mm-dd format. So this is the data, and let me create the schema as well. So I'll say that the first column is the date 1, second column is TS, which is a timestamp, and the third column is date 2. Also, let me create another date for this particular column. I'll say that it is a 24th Feb and it is a 25th Feb. And over here also I can change the column name to say, let me say that it is a updated date, and this one is a created date. So any record that was created in the system, it was created on 24th, and any record that is updated has the updated column name. Also, let me say that this column name is for updated timestamp. So we have the updated date as well as updated timestamp. Now we are going to create a data frame using these columns and dataset. So let me say df equals spark.create data frame, and in the data frame we can pass on the data as well as schema. Once we have passed the schema, let me just do df.show and see what all data set we have. So you can see that we have only one row and 3 different date formats. And if I do a df.print schema, we can see that the schema is currently a string. So now to convert these data into date format, I can apply a toDate function. So let's say I want to create, or I want to update the created column, and I want to cast it as date. So I'll say df.with column, I'll say created, and there is a function called as cast. So I'll say f.call, call name is created, and I'll say that I want to cast it to date. You can say df.print schema, and this should show you that the type is now converted into date. So this is one way to convert the data into date format. Instead of this, you can also use a toDate function. So I can say df equals df.with column, and in the column, let me say that the column name is still created. I can use f.to_date, and inside that we can pass on the column name. So we can pass on this particular column name. So before running this, let me convert it back to a string. So I'll say I'll again create a spark.create data frame, and I'll create a data frame, and you can see that the schema is currently a string. Once I pass the toDate on the created column, you can now again see that the df.print schema, and in the schema you can see that the column is again converted into date. So either you can use dot cast function to cast it to date, or you can directly use the toDate function. And if I go and run the show command, you can see that the date is still intact, and the format is now date. So the data type is now date. Similarly, there is a toTimestamp function which can be used to convert into timestamp, or you can again cast it as timestamp and it will work properly. So I'll say for now we are going to use say df equals df.with column, and we can again give the same column like updated ts, and instead of using the cast function, we can just directly pass on to_timestamp, and the timestamp we can pass on the updated ts. Now if you see over here in the print schema, it should be converted into timestamp, and once we run this show command, you can see that the column value is still intact and the data type is now converted into timestamp. So this is how you can use the toDate function and toTimestamp function. In some cases, you are going to receive the data in the epoch format. So if you go to the epoch converter over here, you can see that the date can be converted into like a epoch time. So here epoch meaning that number of seconds since 1st January 1970. So currently you can see that this many seconds have been passed since 1970, and this keeps on running. So let me see if I convert this timestamp into a human date. It says that it's at GMT it's Monday, February 26, and the time is 6:38, and in IST it is now 27 January and the time is 12:08. Let me convert this particular time into the normal timestamp so that we can use. So instead of that, we are going to have a timestamp column with a proper readable, human readable time. I'll say that I want to convert the epoch time, and we are going to create a proper human readable time from it. So before that, we have to create a new column. I'll say that I want to create a new column, and this column will have the value of epoch. So I'll say df.with column. I'll say column like epoch time, and the value would be f.let, and this would be the value, and I'll cast it as say big int. So once we have this, I'll do a df.show, and you can see that we have a new column called epoch time. And once I convert it into timestamp, we can see that we will have the data in this format. So I'll say df.with column. I'll create a new column. We'll say human readable epoch time or time. So there is a function called from Unix time, and in this function you can just pass the epoch time column name, and it will convert it into a proper human readable timestamp. So once I do this, I'll say that df equals df.with column human readable time, and we'll pass on the timestamp function like from Unix time, and we pass the epoch time, and it should convert it into a human readable time. So I'll say df.show. We can see a new column, and this column will have a value which is readable by us. So it says that it's 27 February and the time is 12 o'clock, like 12:08 and 26. It is similar to what we can see over here. So this is how we can use from Unix time function. Now let's move ahead and see the next function that we have. So there is a function called as a current date. So generally what happens in some scenario that you are going to load the data into the target table. So every time you are going to run any such kind of ingestion job, you are going to add a new column which will be used for audit purpose, which means that let's say I have a transaction like a bank transaction data that is we are going to ingest that in the target table, and this particular column I want to know that when it was uploaded. So I'll add a new date column like current date, and we'll know that okay, this particular data was loaded on a given date. So I'll say that df, let me create a new column called as df.with column, and the column name would be load date, which will represent that the data was loaded on this particular date. So we can just pass on the current date, and this function will create a new column, and this column will have the same values for all the rows. So I'll say df.show, and we can see that we have a load date column available. So this is how we can use the current date column to create a new column with all the current date. Moving ahead, we are going to use date add function. So let's say I have a date for 27th Feb, and now I want to increase it to 28th Feb. So what I'll do a df.with column, and let me say that the new column is tomorrow, and we'll say f.date add. So it's a date add, and in the date add we'll pass on the column name, and we can also pass the number of dates that you want to add. So I'll say I just want to add one, and I'll do a dot show, and you can see that there's a tomorrow column, and we have added a one day to that particular column. So load date was 27th and tomorrow is 28th. Similarly, if I want to subtract one day from a date, I can do with column, and I'll say yesterday, and we'll say f dot date, and is a date sub function, and in date sub function we can pass on again the load date, and we can say that I want to subtract one day from the load date, and we'll see that we have a new column called yesterday, and the date mentioned is 26th Feb. So this is how we can use the date sub and date add function. So let's go ahead and see another function, that is Unix timestamp. We have seen that from Unix time converts the epoch time into the human readable timestamp, and if you want to convert it back to the Unix timestamp like epoch time, you can use the Unix timestamp function. So let's create a new column called as a epoch time 2, and this particular column we are going to apply the Unix timestamp function on the human readable time, and we can pass on the format as yyyy -mm-dd space hh colon mm colon ss. So once we apply this particular function and do a dot show, we can see that we have converted it into the actual format. So the epoch time was 1708-972-706, and once we have applied the Unix timestamp function, we were able to convert it back to the epoch time. So this is how you can use the Unix timestamp function. There is another function called datediff. If you want to find the number of days between two dates, you can use the datediff function for that. So let's say we have two different columns. There is a column called as a created, and there is a column called as updated. So if I want to get the difference between these two dates, we can use the datediff function. But since the updated column is not in the date format, we have to first convert it into the date format. So let me use toDate function to convert this particular updated column into the date format. So I'll say df.with column, and in this we are going to pass on the updated, and we'll say f.toDate. In the date function you can pass on the column name is updated, and we can pass on the format. So currently the format is dd/mm/yyyy. So I'm going to update this column and again assigning it back to the updated column. So once we run this and do a df.show, you can see that the date is now updated into the proper format. So we have the columns like created and updated, and we want to apply the datediff function. So also you can see over here that the schema df.print schema after we have applied the toDate function is now date. So if I want to apply the datediff, I'll say df.with column, and we'll create a new column called as date_diff, and we are going to apply the datediff function. So I'll say f.date, and if you do a tab over here, it will give you a datediff, and we are going to apply it on the two columns. So I'll say f.call updated, and other column is f.call created. So once we apply this and do a show, it should give me one as a datediff. So you can see that updated date is 25th Feb and the created date is 24th Feb. So the date difference is 1. This is how we can use the datediff function. So this datediff function will give you the difference between two dates. Now let us move ahead with the other functions that is available for date. So we have the dayofmonth, dayofweek, dayofyear. So these functions, as the name suggests, it will give you the day of the month, and it will also give you the day of the week as well as the day of the year. So let's see how this function works. Let me apply the day of week first on the updated column. So I'll say day of week, and we'll pass on the f dot day of week. It will give me the day of the week. So since 25th February is a first day, that is a Sunday, so it will give me 1. So let me apply it, update it over here, and do a dot show. You can see that day of week is 1. So if you want to apply this on the created column, which is 24th Feb, we can see that what it provides. You can see that Saturday is the 7th day of the week. That's why the created, when we applied it on the created column, it gives us the day of week as 7. Similarly, we can apply the day of month, day of year as well. So let me say day of month on the created column, and let me say this column as day of month. It gives me that it is 24th day of a month. So on the Feb month, it is a 24th day. Similarly, if I apply it on the day of year, so I'll change it to day of year, and over here as well. So it should be number of days since this year started. So the year started on 1st Jan, and then on the Feb, we have already passed 24 days. So total number of days are 55. So that's why it's the 55th day of a year. So this is how you can use day of month, day of week, and day of year functions. So let's go ahead with the final topic of this video, that is case statements. So case statement is one of the most powerful function that is available in Spark, since this is used to create a new column based on the conditions on the existing column. So let's again look into the customer data that we have, which is this. Let me create a new column using email. Let's say that if the email is Gmail, then we are going to mark it as 1, otherwise we are going to mark it as 0. So to apply this condition, we can use case statement. In PySpark, we have the syntax like when and otherwise. So let me create a new column over here. I'll say df.with column, and we'll say the column name is Gmail flag. So there is a function there called as when. We can pass on the condition in this. We can say that f.when, f.call name is email, and we can say that dot and contains. So there is a function called as contains, and I'll say that if it contains Gmail, then I want to mark it as 1, or dot otherwise I'll say 0. So when I do a dot show, it will give me a new column called as Gmail flag, and you can see that the value over here is 1 for Gmail, and similarly we have a value 0 whenever the email is not Gmail. So let me only select these two columns to make it look better. So I'll say that's dot select, and the column name is email, and the second column is Gmail underscore flag. And in the show, we can say that we want to see 10 record, and we are going to say truncate equals false. The value is gmail.com, and you can see in this column Gmail flag it is 1, and other extensions like Hotmail or Yahoo or any other, you can see that the flag is 0. So this is how you can use the case when function. We can use this function in a like a single when statement, or you can also use the nested when statement. So how we can achieve that? We can again use say df.with column, and the column I'll say that Gmail Yahoo flag. So let's say f.when, f.call email dot contains, let's say we'll say it contains Gmail, then we'll mark it as 0. Dot when, column name f.call email dot contains is Yahoo. We are going to mark it as 1, and dot Otherwise, we are going to mark it as 2. So whenever there is a Gmail, we are going to say that it is a 0. Whenever it is a Yahoo, we are going to say that it is a 1. Otherwise, we are going to say it as a 2. So let me just do a dot select. So the columns that we want to select is email and the GY flag. And we say dot show, say 20 comma false. So let me run this, and you can see that whenever there is a Gmail, like we have mentioned that Gmail is 0 and others are 2, and whenever there is a Yahoo, we would be having 1. So this is how you can use case when statement in PySpark. And that's a wrap for today, folks. I hope you found this video helpful in your PySpark journey. Remember, mastering these essential functions is just a beginning. There are more videos lined up for you. If you enjoyed this video, don't forget to hit a like button and subscribe to my channel. Make sure to check out the PySpark playlist for the additional videos. Got any questions or any topic you would like me to cover? Leave a comment down below. I would like to hear from you. Until next time, happy coding and stay curious.